Good. I was looking forward to have a live, in real life lecture just to end our course, but since today we are not allowed to do it in the school. So some of you who asked for a video conference were quite right. But future studies, this is the future of teaching, I am afraid to say, so we should be fine. Just a small talk before we start with the last lecture. Um, as I checked the podcasts, the last lecture of materials and technologies was really missing, and I remember that it wasn't recorded, so I couldn't make it. So today's lecture is sort of hybrid of conclusions, some more speculations as it is, and also a short overview of technologies, especially artificial intelligence and other uh, phenomena like quantum computing and these things. Just an overview of bits and pieces, and I have been calling it like bits and pieces. Then I will start. During these podcasts and two lectures, we have looked at several themes. We started with image and hybrid poetic image that for me seems to be one of the visiting cards of this new era we are facing. And I have used a metaphoric concept called imagospheric condition, which I think is a present condition uh, massively catapulted by digital technologies. We looked at Facebook, hybridization of documentary, feature film, computer games, digital moving image. Our basic concept was by Daniel Bell, and it describes several technological revolutions, which we could call different modernisms, and his understanding of post-industrial society. Post-industrial meaning that we are entering into the society where much more people deal with something else than agriculture and industry. For design-based disciplines, it is of course slightly problematic because we don't really know when this paradigm for design-based discipline started. And if we looked at modernism in different uh, times and through different criteria, one might say that the design-based disciplines really started this paradigm that is ending now 600 years ago in Renaissance, where a specific way of making projects and making images or projections came into use. And today we witness that this paradigm is being lost and something entirely new is coming instead of that. We looked at several metaphoric things that have been told are the visiting cards of the existing and outgoing new world as the post-truth society. And my metaphoric concept here was looking behind the looking glass, the old name of mirror in English language. What is mirror and mirroring? How we simulate and what are the simulacra that are being used? And several other metaphoric concepts like hypermarket and others were used here. We came up with 7 speculations about digital reality, which I think I have gone through quite concisely. Then we have been looking at the uh, professional level of images from the viewpoint how they are projected and what is their perspective, the conceptual counter eye, uh, and uh, and also I think special case of Johannes van Eyck really makes it obvious how what we see and what we understand from what we see is highly epistemological. It makes us believe and experience the world as it is. So uh, quite a interesting conceptual uh, continuum of time, space, and our understanding of it. I, as a personality within that vision of space and time. Uh, and then we also did excursion into image and the value system of image, where maybe we went too far for the future studies. Uh, for today, I have taken most of the image-related material out of this lecture, and it has been developed into a separate lecture called Composition, where I am looking more in detail how different types of projections and images were used in the history. And therefore, the next year future studies would be less loaded with fine arts image discussion. But nevertheless, the dominant form of perspective, I think it is important to go through within the future studies, because we very often do not really think about these structural build-ups of our cognition through screen and digital technologies led image on the screen. I think fluid perspective is a very fruitful theme that needs to be developed further. I think I've only touched it, but already the small movements of touching it exhibit that it is a powerful and dominant tool, and how it really influences us, we don't know for sure yet. Then, both in the lectures and in the first meeting at school, we were looking at some epistemological schemas of how we can think of reality, and I proposed one way of looking at several realities: the subjective reality, the social reality, and the material reality, or objective reality made of matter and objects. And we also used the metaphoric concept of horizon between the different realities. And then there should have been the lecture on new materials and new manufacturing, which I understood was missing. Therefore, we are going slightly through that material today. And then we come to the concluding speculations of this lecture series and podcasts. So, new materials. I started this lecture series in 2018. So there was the material before 2018, and I used several examples. For instance, new type of textiles, which is called high grade carbon fiber, and check 2020. The product is there. It has developed fine. It hasn't made any revolutionary changes, but it is gradually coming up, and there is no doubt that it will remain. There are always in popular newspapers and magazines some kind of overview of, like this one, new materials invented in 2018 that could change our lives. Here is one of them: the strongest biomaterial, stronger than steel and also at the same time biodegradable, produced in KTH Royal Institute of Technology. 2020 check, no further data after 2018. So some of the materials either disappear, they become they become classified, or the hype was just about nothing. We don't know yet, but it looks like this material didn't get its life back after this first article. Then graphene is one of the key materials that has been around for quite some time. This is the article from the year 17, but already 2004 I was looking at it, and then, as we can see here, the quotation would be: "We are working on flexible, bendable and transparent displays and surfaces that could in future be part of flexible phones, tablets, TVs and solar cells." So graphene basically should be already in use now. But if we look at the last developments of foldable and bendable materials, it is still a 7.8-inch organic light emitting diode display that has been used for this notebook. So graphene has not really taken over the promised products, but graphene is still there. Best products 2020. It is the durability needing objects like this bicycle, but number one product that was made out of graphene was power bank. So a lightweight and strong material for our mobile devices electricity. So graphene is there, but it hasn't developed the way they promised, and we are still missing these huge bendable screens that I was hoping will come very soon. Here is Scientific American, 9 materials that could change the future. Here is meta-aramid fiber, which is very heat resisting and also excellent for colors. 2015, 2020 check. The product is there, working fine. Especially beautiful and metaphoric are these gloves that are cut protection gloves, so you can't really cut yourself when doing hard work. But also brakes and other technological materials that have been using this material. So the product is fine, it is there, it is working, but also no revolutionary changes. Plasticomp creates long fiber composites, and we are hoping to get new mobiles and pads screens, because very often you still get them broken. And 2014 it was promised it will come, and we see today that yes, by 2025 half of the production has gone forward, but actually it hasn't. It is the automotive, electric and electronics, but it hasn't really delivered what we were hoping for the displays and the cover of our mobile phones. But here is the real winner of the long technological revolution. It is the household LED lamp. Already 1972, the blue LED was there. 93, high emission blue LED was developed, and that allowed the different LEDs to be mixed together so that we could get any color of the light spectrum, and it has really been spectacular. And in September 2018, all the other bulbs were already out of the business in EU, and today we are mostly using LED bulbs. And just yesterday I was looking how efficient it is, and I found an article from the United States, and they say that at least 75% less energy, 25 times longer lifespan. And for the United States, it is 44 large electric power plants, and altogether something like 30 billion US dollars in electricity prices. So it is spectacular. And when we think also that the United States, since 10 years now, had started and probably is finishing now the process of double glazing. we can clearly see why US has changed from importer of energy, really selling off the strategic reserves of oil that were kept intact previous decades. So the small but important creations, innovations really have massive effect at the end. And LED bulbs has really, during my lifetime, it has really changed the global situation. Now, how much these new materials are connected to digital reality? I think they are just as new materials. We should not really believe that all of them are the result of digital revolution, but nevertheless, the more materials we look at, they would be impossible without digital design and digital modeling. Here is Kevlar-like fibers that are coming up, but this is really what I was having in mind. The physical and chemical properties of cluster systems and the subnano and nanoscale are often found to differ from those of the bulk and display a unique dependence on size, geometry, and composition. So, a new type of periodic table of cluster elements is really already needed, and that is something that cannot be really developed with digital modeling and computer algorithms. Especially when we go into the biotechnology and talk about tissue engineering and tissue printing, that is, as 3D printing, that is already actively using the digital reality and its potential. And now we've come to quite a how would I say, precarious situation where, as this Guardian article is saying, scientists may have crossed ethical line, and they are growing. They not really human brains. It is the metaphoric stress here for the reader interest. They are called organoids. They are not really brains, but what is true is that they are using the human tissue to grow mini brains or cerebral organoids that in a way act like our brain to a certain extent. So it is the question, how far can we go with manipulating life and life technologies? And just yesterday I was reading in the Guardian, DeepMind AI. This is the artificial intelligence software that has cracked all the games against human beings. So the last one, Go and poker, were recently still unavailable for algorithmic computation, but now these have also gone. And here we see already quite clearly that artificial intelligence have surpassed human capacity. DeepMind IA cracks 50-year-old problem of protein folding. And the article in a popular form explains that protein folding, or the build-up of the serious protein change, including DNA sequences, actually is not just of the chemical compounds, what it is made of, but it is how it is folded, what is the structure of this particular protein. And that has been impossible to solve so far. But now DeepMind says it can show how and why this exactly happens, which means the artificial intelligence really has surpassed average human knowledge and capacity to think, at least. And now for the new materials, maybe not all of them are so new. When reinforced concrete came into being, it was a progressive, innovative material. Then it was slowly substituted with high quality thin steel structures. And today we know that cement manufacturing and concrete manufacturing, as well as steel manufacturing, are one of the most destructive processes on Earth. But instead, we come back to the old and famous material timber. And these timber structures that we see coming up today, they are double important. First of all, timber, if it is stored for a long time, actually contains CO2. So it is a material that keeps their climate change on bay, at least partially. But it also is a very flexible and lightweight material. But these huge structures that an example we can see on the screen would not have been possible with parametrical design and algorithmic computing. These are the backbones of this new material in large spans that allow us to come back to maybe one of the oldest building materials of mankind.